Okay, let's look at number 13 in our sample problems for the SOAP exam practice. All right, in modeling the number of claims filed by an individual under an automobile policy during a 3-year period, an actuary makes the simplifying assumption that for all integers n greater than or equal to 0, the probability of n plus 1 is 0.2 times the probability of n, where P of n represents the probability policyholder files n claims during that period. Under this assumption, calculate the probability that a policyholder files more than one claim. So we were looking for the probability n is greater than 1. Okay, one of the tools we're going to need in this problem is a geometric sum. So remember, if you have n equals 0 up to infinity of a r to the n, this sums to a over 1 minus r as long as your r is, the absolute value of r is less than 1. So that's our geometric sum that we're going to need here. Okay, so let's see if we can find a pattern here. So n greater than or equal to 0. Let's start with n equals to 0. Then we get P of 0 plus 1 is equal to 0.2 times P of 0. So P of 1 is 0.2 times P of 0. All right, well, let's move up to 1. So if n is 1, that means P of 1 plus 1 is equal to 0.2 times P of 1. That is P of 2 is equal to, and now I'm going to replace P of 1 with its expression here, 0.2 times 0.2 P of 0, or 0.2 squared times P of 0. That's what P of 2 is. Let's do one more. N is equal to 2. We get P of 2 plus 1 is equal to 0.2 times P of 2. And P of 2 is this expression, so we're going to replace it here, and we get 0.2 times 0.2 squared times P of 0. So P of 3 is equal to 0.2 cubed times P of 0. I think that's enough for us to deduce the pattern, and we get P of n is equal to 0.2 to the n times P of 0. Okay, we have this recursive definition, so we need another tool so we can solve for P of 0. And then once we know P of 0, we can figure out P of n for any n. So remember that if we sum up all of our probabilities, so n greater than or equal to 0, we shall get 1. So what does that look like? We plug this in. That's the sum of n starting at 0 up to infinity, P of 0 times 0.2 to the n. So this is my AR to the n formula that I talked about at the beginning. So this sums to P of 0 all over 1 minus 0.2. And that sums to 1. Because it's the sum of all probabilities. So this is enough to show us that P of 0 is 0.8. All right, we're getting there. Now, if P of 0 is 0.8, remember what P of 1 is. P of 1 is 0.2 times P of 0, which is 0.8, so that's 0.16. Now, what we want is the probability n is greater than 1, so it's going to be 1 minus the probability that it's 0 minus the probability that it is 1. The rest of that is greater than 1. So 1 minus 0.8 minus 0.16, we end up with 0.04. Our answer is A.